All right. Hello. Good afternoon. Oh my goodness. It's not easy to set up a live demo with physical devices, I have to tell you that. Thank you for coming to this session. My name is Ray. I'm a developer advocate from Google. And if you have any question about this session, about Kubernetes or anything I talk about here today, please feel free to contact me at my Twitter handle at Satanism. Whew. I'm just a developer, engineer. I've done a lot of consulting work and architectural work before. But my other passion has been traveling. I love to travel, and I love to take photos. Whenever I travel, this is the backpack I use. Every time I go onto a tour, on a trip, backpacking around the world, this is the backpack I use, and that's the one I'm carrying today as well. And I take a lot of photos, and if you'd like to see some of the places I've been to, feel free to see my photos at Flickr as well. I don't know how much time I have, so I usually run over, so I'm going to skip over some of the introduction and just tell you about a little story of this thing, this little project I was very fortunate in terms of being able to participate in, and it was just complete coincidental. Nothing was planned at the time, and I just met a bunch of really passionate people at a conference, and at the right time, just before another big conference, just right before DevOps Belgium, which is where I spoke, and we're able to do something pretty fun. It's something that not that everybody got a chance to do before. I travel a lot, and these are just a few places I've been to in 2015. Yeah, I've been to many of the offices from my company as well, but this is a few places I've been to. But the most special one to date, and the conference I've been to date, was called JFall. Anybody know about JFall? Anyone from Netherlands? Yes, one. All right, awesome. Woohoo! Yeah. So JFall is a Java developer conference. Any Java developers here? All right, I'm a Java developer myself, and yeah, so it was a great Java developer conference organized by NLJOG, the Java user group there, and I gave a talk on microservices. Anyone heard about microservices? Yeah, yeah, I think many people talk about microservices and micro-routines and micro everything. So after my talk about microservices, I was walking down the hallway, just like the exhibition hall down there outside, and then I saw this thing, this beautiful Raspberry Pi cluster, just sitting on somebody's desk, and the lights were blinking, okay, because they actually have some network activities going on. And I thought to myself, oh my goodness, that is so cool. That is so cool. And when I first saw it, I thought, wow. Like, did you like 3D print everything? Because everything fit and fit perfectly. Just look at the switch on the top. That's a network switch. It just sits perfectly on the Raspberry Pi stack. All right. And then look at the power hub at the bottom. It just fits perfectly inside the Raspberry stack as well. And look at the cables. Look at the colors. I swear, I think they spend a lot of time, making sure it looks good. and it does. And I was just there. I was mesmerized. I was looking at this thing, and I think I stood there for like an hour. Okay, I did. I was just looking at it, and I was talking to a few people who built this, which I will introduce later in the slide because they couldn't make it today. But I was talking to them, but the whole time I was just being mesmerized. I was looking at this. I was staring at it for an hour. Yeah. I forgot what they said, to be honest, but I was looking at it, and I was thinking through a few things. Okay. Well, number one, a Raspberry Pi 2 has 4 cores at 900 megahertz each. So with 5 of them, this is a 20-core cluster, right? That's significant. And if you look at how it's being connected, I don't know if anyone been to a data center before or seen a real rack, a data center rack. Yeah? No? A few people, right? And I think that's one of the things I want to talk about later in this talk is, to many of the developers, myself included, I rarely had a chance to go into a real data center to see what's happening behind the scenes. But I have. So when I saw this, I'm like, my goodness, this looks like a little data center. Because you got these little slots for the computers, and then you have to hook it up to a backbone, and with the network plan, which is the switch on the top. It's cheap. It's like $10. And then you power everything through this central power source, power distribution, which happens to be a hub. It's just a regular USB hub. Oh, and by the way, one of the guys over there, he also had a USB battery. So to me, that was like, oh my goodness, if the power ever went out, they can use that as a UPS, right? So that was the thing that was going in my mind. And because I was talking about microservices, I'm like, microservices was developed by micro teams, so I think that demands a micro data center to run the microservices. And that was really what I was thinking about. But when I was standing there for like an hour, I was thinking through some of the history, okay, of how I grew up learning about computers, learning about networks, and learning about development, learning about programming. Okay. That was the first computer, the type of the first computer I ever got a chance to use. Anyone used this one before? Yeah, quite a few. It's black and white. And I was learning how to program with BASIC at the time. And there was no internet. There's no Stack Overflow. There's not even copy and paste. Okay? The way I used to learn is I read a book, I flip through the pages, I try to copy with my hand to the letter, to the character of the program that's on the page. And that's how I learned how to program. If there was anything that goes wrong, there's no internet for me to copy and paste. There was no stack trace. Okay? I could not go to the internet and look up what went wrong. So that's how I learned, which is fantastic. I think it's the best way for me to learn. Nothing very good about this computer, to be honest. I mean, it has 40 megabytes of hard drive, the one I had. The Raspberry Pi, I have 8 gigabytes of this micro SSD in here. So time has changed. The one thing that hasn't changed, which is one thing I remember, is just the feel of the mechanical keyboard that came with the computer. To this date, I haven't found any mechanical keyboard that come close to the feeling I used to have. And then I had the fortunate opportunity of upgrading straight to a 486. It was 33 megahertz. I think I overclocked it to 66 megahertz. That was the network card that I used to use. I mean, it's not even a Ethernet cable like that one. It's the old BNC cable, right? Coaxial cable. And you have to connect it with a connector like that. Anyone used this network before? Yeah. Don't forget to put the terminators on the both ends, because otherwise, nothing will work. And I was running Novell network and IPX, not even TCP/IP, right? So things have changed. I had the fortunate opportunity to play around with the network with physical devices. But today, I think I only have one laptop. I don't have any other desktop in my home anymore. Anyone has more than one desktop in your home? Yeah, that's pretty good. Network them together? Yeah, quite a few. I remember pulling a network cable from my brother's room through the roof, over the attic, and then goes into my room. And that was fun. And then I upgraded to a Pentium, 90 megahertz. I, of course, overclocked it to 100 megahertz. And that thing was expensive. That was like, oh my God, I think it was $900, $900 US at the time for a single chip. And then you think about the Raspberry Pi, it's $35 for one. Okay, that's like 30 euros. 4 cores, that's like $6 US for one 900 megahertz core. And compared to that, like, that was nothing. And I had the opportunity to join a startup. And at the time, it was like late 1990s. And this startup ran everything on a single machine back then. And that's really what it was before. They had the email server on a single machine. They had a SQL. It wasn't even MySQL. There was no MySQL at the time. It was running MiniSQL. Anyone use MiniSQL before? No? Yeah? Maybe a few. Yeah, MiniSQL at the time. And then Perl was everywhere. There was no PHP or Node. There was just Perl for every web development project with CGI and stuff. And everything was on this single machine that was stored in a closet. And of course, nothing ever goes wrong with the machine. That brings to a different concept. Is back then, you run all these processes on a single machine. I mean, people still do that today. But the problem with that is, if one of the processes runs away with 100% CPU utilization, every other processes will get affected, right? And that's what happens. Is like all right, I wrote some code, and it ran away, it was 100% CPU process, and we couldn't get any emails, and that was my fault. And now today, right, the gentleman previously just talked about containers, where you can actually containerize your workload, containerize your processes, and make sure that kind of thing doesn't happen. And then we have more computers. Actually, this is not mine. This is actually Google's old server cluster on the left-hand side. So I was told. I was not at Google at the time. Okay, so it's the same thing. Like that. They just had more of it because they had more money, I think. But they network everything together, right? And then they moved on to like racks and racks and racks. By the way, these are just some old photos that you may have seen before, or maybe not. And they moved on to even more racks, and even more. This is mind-boggling, and even more, okay? Data centers, yeah. And they moved on to even more. In fact, many technology companies, or even your enterprises, the companies you work at, probably host something in some data center, right? And to me, is that as a software developer myself, sometimes I forget, okay? Just like I did a poll, like very few people had a chance to go into the data center to see what it actually is. I remember when I was a consulting manager watching over an enterprise project. Before the project even started, I have to give the line of business a set of resources I need to use when the project is done. And I give them like, hey, I need, 5 machines, and I need 3 environments, or 4 like staging, and staging prod, and all that stuff, and how many CPUs or how many computers I need. And then they said, okay, yeah, we'll get that to you in about 9 months. Does that happen to you? Anyone have that story? 9 months, 6 months? Yeah. 1 month, anyone getting 1 month? Yeah, some people do. But then at the time, I didn't appreciate, why does it take that kind of time? Because I forget, at the end of the day, software runs on hardware. Software runs in these data centers. That's composed of hundreds of machines. And some people have to physically ship that hardware to you and put it into the rack, screw them together, right? And connect the cables, make sure there's enough power to power everything, make sure the network is working, make sure that the backbone is there. There's a lot of things that's happening behind the scenes. And to me, I forget about that. And as a software engineer, like, we forget. And another thing that we forget, or I forget, is that everything that you're seeing here, something will fail. Something will eventually fail. It's not just the software, but every component that you see here might eventually fail. Okay? Whether it's the switch, the hard drive, the CPU itself, I don't know, the hardware, the power, the cables, everything will eventually fail. And so, as an architect, what I have to think about is, for mission-critical applications, right? Everybody's got to think about failovers. What happens if your database goes down? High availability, right? Do you have 3 nines, 4 nines, or 5 nines, or something that's like a unicorn that you're chasing after? How do you make sure that your application is fault-tolerant, right? If something goes down, how do you bring it back up? And throughout the many, many years, the technology has changed and shifted significantly. And so when I was looking at this cluster, I was like, wow, I can really build something with this and potentially put Kubernetes on it, which is fun. Now, how many people here heard about Kubernetes? Wow, everyone. How many people used it? Yeah, that's what I thought. Why not? How many people saw my session yesterday? All right, I'm so happy you came back. And so everybody heard about Kubernetes, and why don't I just go through some high-level stuff, and then I'll show you what it looks like in real life. So Kubernetes is an open source project that was contributed originally by Google. It's created based on our many years of experiences in orchestrating and managing containerized workload. Okay. And it's fully open source. It's written in Go, and it supports multiple kind of cloud services and also bare metal computers as well. And what it does is that if you have a container that you created on your machine, you can just ship it to an entire Kubernetes cluster, which may be composed of 2 machines, 3 machines, or 100 machines, right? You can ship your containerized image to a repository, whether it's Docker Hub or a private repository of your choice. And then you write the configuration file to tell Kubernetes how to get to this image and how to run it and how many instances of this container you want to run, and also how much resource you want to give to each one of these instances. So for example, you can say, for my SQL server, I just wanted to be using 1 GB of RAM and 2 cores of the CPU. And you give that information to the Kubernetes master, which is a service that will take that information, and they will consult the scheduler, which is a component in Kubernetes, which will determine how and where to run that container image. And so the scheduler is going to check with every single machine that's under its control. And remember, this is a cluster, so there's more than one machine here. And every machine that's under the control of Kubernetes has this component called kubelet running on it. Okay? So the scheduler will go ahead and check with the kubelet, check with that machine to say, hey, do you have enough resource to run this? And if you do, go ahead and pull down the container image and start executing it. And it's going to be able to do this through as many instances as you need to have. Okay? And it's fully open sourced. Like I said, I think we have more contributors from outside of Google than Google itself, which is great. It's a fantastic and vibrant open source community. And if you like to join the community, feel free to, you can send your issues to GitHub. You can join their Slack channel. You can find a lot of these community-oriented information directly on Kubernetes.io. And one thing about Kubernetes, which I'm going to jump through very quickly, is the concept of replication controller. Okay? Basically, what it means is that, well, in Kubernetes, the most basic atomic unit that you can control is called a pod. Okay, it's not a container. I know I talk about containers all the time, but the basic unit in Kubernetes that you can control and manage is called a pod. A pod is basically a collection of containers that live and die together, that have to work together. Now, you might be thinking, well, could it be like the front end and the back end and the MySQL server? And I would say, no, that's not the case, right? You don't want that single instance to live and die together. You want to have them separated by layers, right? So it could be your application and maybe something that the application needs to use, like an application collector or a metrics collector. Like those 2 containers can live and die together, and they can be belonging to a single pod. In many cases, there may be just 1 container in a pod, which is fine. But the replication controller is responsible for making sure that the number of replicas, the number of instances of the pod that you have, matches the number of instances that you want. So when you tell the replication controller to say, I need 2 instances of my application running, it will make sure that's the case. If you tell it that if you have 1 instance of the application running, you'll just take 1 away and make sure that there's 1. And in a failure situation, like this one, where you have 4 nodes, physical or virtual machine nodes, that's running Kubernetes, kubelets and stuff is under Kubernetes control. And you have these pods running, like the pods that's in blue. And if one of the machines goes down, what happens? Kubernetes should be able to detect that event and understand that, oh, shoot, I wanted to have 4 instances of my application, but I only have 3 now, and so it is going to reschedule it to another machine that has the capacity to handle it. Okay. And in these pods, right, all of these pods, these containers, these instances, your application instances, they all expose some kind of service through like an IP address. And you are able to expose those services via a single stable IP address, and we call that a service, okay? So you can, it's essentially a load balancer that you can create that will then route the traffic via that single IP address and then distribute it to individual containers that you have running in your cluster of machines. Okay. So Kubernetes is fault tolerant in that sense, and that is actually where I got the idea of putting Kubernetes on Raspberry Pi. And I give this idea to Arjun. Arjun is a Java developer at Quintor, and he and his team were the people who created the Raspberry Pi cluster that I showed you previously. And I told them this idea, and they're like, yeah, we can do it. And I gave them a link that has nothing but like a bunch of command lines, and nobody had really done this before at the time, I think. I mean, there are many multiple concurrent projects at the time, and I just gave them a link, and they came back in 3 days and said, oh, we got this done. And that was over the weekend, okay? They love technology. It was over the weekend. And the very next day I thought, okay, how do we demo this? We need to be able to visualize it, so we need a visualizer to actually show everything. And so we spent evenings, like just hours and hours in the evenings to, like in 2 nights to create the whole experience. And Arjun is also using this as a teaching tool, just like I said. Many people don't really have the experience to operate with physical devices that's networked together and to be able to simulate these fault-tolerant situations. So what he has built was they have five Raspberry Pi 2s. They got the SACTAs, the switch, and all that. The cost is just about plus minus $400. In my slide, you'll actually find links to a blog at Kubernetes, blog.kubernetes.io. You can find all of the components that was used to build this Raspberry Pi, and also the software that was used and installations that were done to install this. It uses many open source software. It was using Hyper Linux, which comes with Docker pre-installed, which is really handy. It uses etcd because Kubernetes and some other components needs etcd to kind of distribute the information. It has Docker, it has Flannel. Anyone heard about Flannel before? Yeah, some people have. Yeah, it's like, it's this one thing that can create this overlay network. Okay, so every pod can have this private IP address on every single node, but from that pod, from like the pod instance on my computer, when it needs to talk to a pod instance on your computer, it has to go through some kind of routing, right? And you can do that through the Flannel overlay network. Okay, so that's basically what each of the nodes is doing. I kind of talked about this before. Every worker has the kubelet, and then you have the controller manager on the top and the API server. Okay, and then I'm using Flannel for the overlay network that creates this 10.1 IP range that I can use, and that's what every pod will be getting. Okay, but I added something new, and that, by the way, that is my Kubernetes cluster right here. Because I had to carry this from the United States to here, rather than taking 5, I was only able to take 3 because I have to go through the customs and all that stuff. But I do have one more thing attached to it on the very top, and that is a 250 gigabyte storage. Okay, and what I wanted to do was to basically also demonstrate the persistent volumes in Kubernetes. Because what you can actually do is you can have like a group of your storage devices. You can actually share that and have Kubernetes manage the mounting and the unmounting of those volumes. So what that means is if your pod, if your container, like a MySQL container, needs to use a persistent volume to store its data, and it's currently running on machine number 1, and if it got rescheduled to machine number 2, you have to carry the data over with it, right? So Kubernetes can actually manage that for you by using what's called persistent volumes and persistent volume claims. So as the pod shuts down on machine 1 and then moves to machine 2, the volume will be mounted for you as well. Okay, and for that, for the demonstration I'm about to show you, I'm kind of using LVM, which is a volume manager. So I'm creating a volume group, and then I'm creating these small volume pieces, like 1 GB or 5 GB pieces from the 250 GB storage, and then exposing that via NFS, and Kubernetes can figure out how to mount NFS volumes for you as well. And you can build this too. Anyone wants to build one? Yeah, anyone wants to have one? So you can build one as well. Just go to blog.kubernetes.io. You can find the shopping list and the installation procedure. And someone actually created this Kubernetes on ARM project, which has really, really good instructions on how to set this up. Okay. So yeah, that's what we're here for, I think. So let me show you a little demo. Okay, I'm just going to switch over. Okay. Very good. So I have here a visualization tool. Let's see how much time I have. 20 minutes. Good. So in this visualization tool, you can see that I have 3 nodes running here. They are in the 192.168.2 range. And I have 101, which is the top Raspberry Pi here, 102, which is the second one, and 103 is the third one. And it's very, very important that you remember that, because later you will see what I'm about to do. And these boxes in the bottom, let me just go through one by one, okay? The blue box is a replication controller, and its name is Hello World, okay? The gray box, that's a pod. In this case, my pod, it contains just one container, and that's actually a service. That's a service. It's a Hello World service written in Java. Okay, and I'm exposing the service, exposing these pods via a service, which is a load balancer, which is in the box that's in green. And all of these things are running in this Raspberry Pi cluster. So what I can do, for example, is I can scale the number of instances of this microservice that I've written. And I can say, rather than having just one, let me get 3, okay? And that's going to scale this cluster, if it works. Oh, there we go. Oh, that was quick. Yeah, that should have updated by itself, and I'm not sure why it didn't. So now you see that there are actually 3 of these things running in the Raspberry Pi. And not only that, you can see that every service is actually running on a different node, okay? So you can see that the first gray box is going to 101, that's the first box, and then 103, and then 102, okay? And what happens if I delete one of these pods? If one of these pods goes down, what happens, right? Well, the replication controller makes sure that there are 3 instances running. So if I were to say get pods, and if I were to delete one of these pods, just watch very carefully. I'm going to delete the one that's on the, I don't know, whichever. I'm going to delete that. Oh, wait, just watch carefully. So something got deleted, and something got restarted again. Okay? So in case something goes wrong with your application and it shuts down, Kubernetes will know that and then restart it for you. Okay. And just to show you that the service is working, let me come back to here. Hopefully it's working. Let's see here. So I can do a curl on the service, and that's the service URL. That's the load balancer that's being exposed. And it's a really simple Hello World application written in Java. So if everything works, yeah, there we go. And that's, well, that's no good. Yeah, there we go. So I know there are some issues with the networking that I just set up here, but for the most part, it works. And let me just show you, and I kind of know why sometimes things don't work. And for example, if you go to each node, you can see that this is a Docker bridge. And that has the 10.1.89.1 IP, but that should be coming from the Flannel overlay network, which has the 10.1.89 network. Okay, and if I go to this other thing, that's on 10.1.1, and that's 10.1.1, so that's fine. And then if I go to here, do ifconfig, I should have the Flannel here running 71 and 71. Okay, very good. Now, What's really fun with this is that you can actually pull the plug right now on one of these things, and it should still work. So, any volunteers? Any volunteers? Just one person, maybe one person in the front who wants to try this out. All right, come on up, come on up. All right, give this gentleman a hand too. He's brave. Okay.
Which one?
Which one? The first question was which one? Why don't you come around here so people can see? All right, just remember, that's 101. Just remember, that's 101, 102, and 103. And currently, we have these pods running on different machines. Just don't pull. Just don't do just don't do the first one. Yeah. The first one has a network to my computer, so don't do the first one. So the second one or the third one. And actually, use the network cable for now. Yeah. Oh well, I can't be. Now, I want everyone in the audience to pay attention because this is going to happen very, very quickly. Okay. Okay. So why don't you pull one of these things? Yeah. I think that should work. Yeah. Okay. So now watch. So Kubernetes should be detecting, hopefully soon, that the node goes down, and very soon, it's going to realize the pod has gone away. And then it's going to start another pod for you. And just like that, you have fault tolerance. And it should also take away the other pod as well, which is happening right now. So for example, if I go kubectl, get pods, it's going to say one of the pod is terminating. I just don't have that shown here. Okay?
Job
done. Job done. Yeah, very good. Now wait, hold on. You gotta put it back. Now watch it as he puts his network back. Yeah, just don't destroy my cluster. Thank you. All right. So now we have 3 pods running, right? And oh my goodness, that came back quick because I only disconnected the network. So as he was walking back to his seat, you can see that the node just came back up. Okay. Now, nothing is being scheduled on that node currently, but what I can do is, for example, I can scale this again. So I'm going to scale to 4 instances, and there you go. Kubernetes realized that node just came back, and I rescheduled another pod, and it was able to use the instance that just came back, right? Which is really awesome. And it's while doing that, I hope this works. Yes, it does. Right, my service still works. In fact, when you unplug and stuff, all the services are still working, which is not a problem at all. But that was pretty easy. That was kind of fun, but that was kind of easy. What I can do then is to take it another step further and say, well, what about stateful workload? What if I have data? What if I have things I need to write on the disk? Because for those things, you're not, you have to carry the data with you. You cannot just stop and start and hope it runs somewhere, because if the data is not there, it doesn't make any sense. So for that, I'm going to do this. For that, in Kubernetes, there's a concept called the persistent volumes. Okay? And basically what it means is that you can create a definition of what that volume should look like. And that is called the persistent volume kind. Let me blow this up a little bit. Okay, can everybody see that, kind of? Yeah, let me blow this bigger. There we go. Okay. And by the way, this is a YAML file that you can give to Kubernetes to create like a persistent volume definition. And this volume is called MySQL volume 1 and has a capacity of 1 gigabyte. And it's read write once. So only one pod can mount it and read write. Okay. Because it is NFS, you can actually specify what's called a reclaim policy, right? Because with NFS, it's really just a directory that's being exposed, that's being exported. And if this volume is going to be used by some other pod that's not MySQL, right, or a new pod, you have to wipe it clean before you give it to the application that needs to use the volume. That's 1 gigabyte large. And then you give it, so recycle means whenever you give it back to another pod, you're going to clean it out before you give it. And then you have these, the ways you can connect to this volume. In this case, I'm using NFS. I'm exposing everything via NFS. And the way I'm doing that is, of course, doing the fs export fs. And I'm just basically exposing the volume here. Really easy. The volume itself is here, MySQL volume. But if I see mount, oh, that's too much. MySQL val. No. Well, that's no good. Oh, yes, of course. I forgot one cable. Yeah. So this cable goes to the 250 gigabyte volume, which is connected on the master. Okay. So once that's connected, oh my goodness. Let me see the message. So I have the device up and running. That's SDA, and I should see a PV display. So I'm using LVM. So I have one physical volume here, which is SDA. So with LVM, you can combine multiple physical volumes together, multiple devices together. It's just that I have only one, so that's all you see. And then I have the volume group. Oh, sorry, yeah. So volume group is the one that aggregates all of the physical volumes together. And then I have a logical volume, which is which I carved out to be 1 gigabyte in size. Okay. Anyone used LVM before? Yeah, quite a few. So I don't have to demo this. That's great, because I don't remember the command lines. Which, I'm just kidding. I have it written somewhere. So what that means is I should be able to mount my volume, data. Wait, here. Oh, wait. Mount, device, data. Wait, where is it? Oh, maybe because I did this too late, so when this starts, it's just not there. Okay, well, that's okay. But imagine that the mount, imagine the mount is actually in the volume, and it's this one, okay, it's there. It has data on it, but it doesn't matter. And I created this persistent claim, and the way you do that is to do kubectl create and MySQL PV, which will send MySQL send Kubernetes the definition file, which I have done already, so I can do get PV. Okay. But for Kubernetes pods to be able to use this, you have to also create what's a claim. Okay. So persistent volume is just how you connect to the volume, how you mount it. The claim is the ticket that you need to be in your hand in order to actually use it. Okay. So here I have created a claim, MySQL PVC, persistent volume claim. And again, it defines the access mode for the pod and the storage requirement for it, which is 1 gigabyte. Okay. And then in the MySQL definition on how you want to run it, I'm running a replication controller here, which I only just want one MySQL master running, because you don't, the other way is just, I didn't have time for it, but just one MySQL running. And the storage, you can actually specify here in the volume mounts. For the mount path valid MySQL, which is where it stores the data, I have to mount it into MySQL persistent storage, which then is here at the very bottom. It's mapped to MySQL persistent storage volume, which in turn is referencing the persistent volume claim, which is defined to be trying to getting something that's from the NFS. Okay. So if I run this, so let's create F, MySQL RC. Oh wait. Did I just do a get and create at the same time? That doesn't make sense. All right, so if I do a create, and this is the hardest part of the demo, and I have my SQL running here on 102, and it's also exposed as a service port 3306. I'm not sure if I can connect to it at the moment, but let's try it. 168.2.102.2306. Oh, sorry. Yes, okay. So what that means is I can actually go in there, so I can do a MySQL u root p host 192.168.2.101. Anyone know the password? It's your password. There we go, your password, that works. Use app, because that's where the database is. Show tables. I'm going to delete that, delete tables. Hello, oh wait, delete table, hello. Oh wait. Drop table, yes. So let's see what's in here. Let's see what's in here. All right, so there's something in here. That's fine. Hello, FOSDEM. I did this yesterday. So why don't I do something else? I'm going to insert into help. Hello. Greeting. I tested my colleagues on this. Nobody seems to remember how to write SQL anymore. Hello there again. Oh my goodness. Wait, of course. What's that? Oh, this one, yeah, of course. All right, so I wrote something here. How much time do I have? So there you go. I'm gonna exit. So now watch. I only have 5 minutes left, so this is good, because if it doesn't work, I can just go away. So this is running again on 102. So by process of elimination, 103 must have not worked. So if I were to pull this again, let's do it. So if I were to pull this again, I only had like 5 minutes to set this up earlier to test it. Okay, so that's gone. That's good. So 02 is gone. So hopefully it will reschedule my SQL to 03. Fantastic. So far, so good. Wait, how much time do I have? And it's starting, which is great. I have until what? 7 minutes. 7 minutes. All right, very good. What? 7? That means I have to show everything? Okay, so I can see that another MySQL got started, it's running, and the other one is terminating, which is great. And if I do pods -o wide, I should be able to see that, well, here. MySQL is now running on 103, which is the third node. Okay? But that's no fun, because how do I make sure the data is there, right? There are only 2 ways to find out. I'm going to do the safe way right now, which is, right now I'm logging to 103. And if I see the mount, I can see that there's a NFS mount here that's mounted from my master node, which is great. So far, so good. And it's being mounted into this directory, this lone directory for the container. So if I see what's inside, that's good too. I have the data here. Now the ultimate test is actually to see if the MySQL connects, which I'm not 100% sure right now because there were some issues. But let me see here. Let me do a telnet first. Oh, it connects. Okay, good. So I'm gonna go into MySQL. Again, this is going through the service redirects. Okay, this is not. I'm not cheating here. There's not a separate MySQL running on my master node. This is actually routing the traffic to another node, and it should have the same password. And if I use the tables and show tables, live demo, start from hello. Are you ready for this? Because I'm not. All right, here we go. All right, I got 2 there. Thank you. Now, of course, in real life, you don't want to do this, right? Because you want to make sure that MySQL shuts down gracefully and you have to deal with the log. So this is purely for demonstration purposes. But you can see about many of the other use cases that you might otherwise have. For example, in Kubernetes, I'm not sure if it's the current version or the new version, they will have these like shutdown hooks, right? So you are able to make sure that you're gracefully shutting down your applications and also being able to start it with like a pre-start hook as well. So let me pull this back in. Whew. And why don't I go to the slide? And I don't think I have many things here to say. All right. So yeah, I don't have any other slides, which is great. So thank you very much for your time. That was it. Thank you. Any questions? Questions? No? Yeah, yes, there's one question.
So earlier you showed that when a node went down, the service was still running.
Yes.
And when it came back up, you could reschedule with listing more replicas. But can you also make it automatically reschedule when a node comes back up online? You see, you have 2 services on one node and 1 service on another node. Can you make it evenly distributed again?
So I think what you're asking for is when a new server comes online, automatically rebalance the load,
yes.
right?
Yeah.
Not at the moment. Yeah, not I know of. Not that I know of. Yeah, but that's a good feedback. I'll take it back.
Thanks.
Yeah. Any other questions? No? Well, good. If you want to see the cluster, feel free to come down. You can pull the block as much as you want.